In this lecture, we're going to set up our very first coroutine type, and we're going to use it with the co-await operator. Now, we have seen that in C++20, we don't have actual coroutine types we can use right away. What we have is an infrastructure on top of which we can build our own coroutine types. And we're going to do just that. We're going to use this coroutine infrastructure, and we're going to set up our coroutine type, that we can in turn use in our own coroutine functions by using it as a return type, as we see here. So we are going to do exactly what we described in the last lecture. We're going to set up a structure. This is going to be called the coroutine type, and this is going to be our coroutine type. This is named creatively. And we're going to nest a promise type structure inside as a requirement of the C++ standard. And this promise type is going to have a bunch of methods. We're going to put in the absolute minimum. So we're going to put in a return object method, an initial suspend method, a final suspend method, and an unhandled exception method. And we're going to rethrow this exception to be handled in whatever code is calling our coroutine here. This is what we are setting up. Don't forget that we have a coroutine handle, which is going to be our key to get access to coroutine information that we have stored on the heap. And once we set up code like that, we will be able to set up our coroutine function just like this. And this is going to be a coroutine because we are using a co-await operator inside, and this is going to return our coroutine type. This is a requirement in C++. Most coroutines you're going to see are going to have a coroutine type as a return value, and this is going to be your handle that you can use to manipulate this thing in your C++ code. For example, you see here, we are creating a variable called task, and we are calling our coroutine. This is going to allow us to use this thing in our code. For example, we can use this variable to manipulate our coroutine. For example, here we are resuming it, and you're going to see that we are able to use code like this in our C++ program. Another thing you shouldn't forget, which is really important, is awaitable types. And these are things you can use as operands to your co-await operator. You see that if we say co-await, we are passing in suspend always as an operand. This is going to tell the compiler that we want to suspend when we hit this suspension point. But if you don't want to suspend, you can pass the suspend never awaitable. And this is going to tell the compiler that you don't want to suspend if you hit the co-await point. You're not going to suspend. Code is going to keep running in your coroutine until you hit a suspension point that is using something like suspend always to suspend, and your coroutine is going to suspend. And suspend always is suspending because we are returning false in our await ready method. If we don't want to suspend, we should return true in our await ready method. And this is going to tell the compiler that we don't want to suspend. You see, this is creatively called suspend never. I realize some of these things may be in the blue, so we are going to head over to Visual Studio Code and play with us step by step. But before we do that, there are a few things you need to remember. What we're going to do here is going to require a C++ compiler that supports C++20. And to be able to use coroutines, you have to enable them in some compilers. For example, in GCC 10 or 11, you need to pass the F coroutines option. If you don't pass it, your compiler is not going to understand coroutine code, so you should remember this. But in the compilers from Microsoft, if you are using a version that is greater than Visual Studio 2019 and this version, you are just going to be fine using coroutines. So this is what I am going to be using to run this code, and we're going to see how this works. Please note that if you don't have access to any of these compilers, you can use an online compiler. OneBox is a good example. It has GCC 10, I think, and it is going to work just well for what we are going to do in this lecture here. So let's head over to Visual Studio Code and play with us. Here we are in our working folder. The current project is co-await. We will grab the code from our template files as we always do, and we are going to put them in place. And we are going to open this in Visual Studio Code by dragging and dropping here. This will give us our main CPP file. Let's clean this up a little bit, and we're going to remove what we don't need. We want to use coroutines, so we are going to include the coroutine header. We have access to this. And one thing you need to remember, if we are using the GCC compiler, we need to pass a nef coroutine flag. So let's go ahead and do that. You remember that in VS Code, we have to change our tasks.json file to change the options we pass to our compiler. And we will go after our C++ standard line here and say f coroutines. I think this is what we said in the slides, and we're going to put a comma here. This is going to pass this flag if we happen to build with our GCC compiler. The compiler from Microsoft is not going to need that. So if we just call cl.exe, we are going to get access to whichever compiler is enabled in our current terminal here. Let's bring up a new terminal window, and we're going to try and run the compiler from Microsoft. And this is going to tell us the version, I think. So this is the version here. And this is the latest version from Visual Studio 2019 16.10. And this is actually C++ 20 feature complete. This is what they say. So we should really have access to all the features from C++ 20 by using this version from the compiler from Microsoft. So we are going to use these things. If you are using GCC, remember to enable the f coroutines option. If you are using Clang, you will have a few more things to do because these coroutine headers live in something we call experimental, if I remember correctly. So you will have to search for that. I am going to use GCC and the compiler from Microsoft because those are the compilers I am most familiar with. But Clang is also going to support most of these features if you change the locations where these headers are located. Okay, so the first thing I am going to do is put in my coroutine type that we set up in the last lecture. This is going to be a struct called corotype. It is going to have a nested class called promiseType. This class is going to have a bunch of member functions. We have a getReturnObject member, which is going to return our coroutine type. So it should return this type. We also have a bunch of methods. We have initial suspend and final suspend. Initial suspend is going to decide whether we suspend the coroutine on first call. Final suspend is going to decide whether the coroutine state is destroyed when we hit the end of our coroutine function. Unhandled exception is going to decide how exceptions are going to be handled. In this case, we're going to rethrow them in whichever scope called our coroutine function, and that's where they are going to be handled. If you don't handle them there, you're going to get a crash because unhandled exceptions are really bad in your C++ program. So this is the absolute minimum we need for our code to compile. And one thing you shouldn't forget is that we also have a coroutine handle member variable here. And this is going to be the key we use to manipulate our coroutine, as you are going to see in a minute. So let's try and see if this code actually compiles. We are going to try and play with this in steps. And we are going to see that we have an error. And what do we have here? We have an unrecognized command line option. F coroutines. Did we mean F coroutines here? Yes, we meant F coroutines. So let's go back in our tasks.json and we're going to change this a little bit. Let's go on top and say f coroutines and not coroutines. This is what we said. We can close this now and try to build again. This is a good way to find mistakes. We are going to use the GCC compiler and let's wait and see if this actually compiles fine. And we see that the build is good. So this is a good sign that our coroutine type is actually compliant with C++ 20. Now, I have seen some irregularities with these things if you use different compilers. I am going to try and use the compiler from Microsoft and see if this actually works. And we see that the build is good, so we are fine with the compiler from Microsoft. And this is a good starting point. Now, I have said that these methods are required and they are the absolute minimum you need in your promiseType. If either of them is missing, you are going to get compiler errors because the compiler is not going to recognize this as a valid coroutine type in C++ 20. So for example, if we try to compile this code using the compiler from Microsoft, the build is going to be good because we are actually not using this coroutine. But if later we get to use it, we will get compiler errors. Let's try all the others. And this is a really good way to try and understand the behavior of coroutine code. And the build is going to be good. Let's try to use our GCC compiler and see how this behaves. The build is good. So if either of these methods is missing, we are going to build because we are actually not trying to use this coroutine type here. Let's take them all out and see what happens. For example, we can actually take everything out. Let's try and comment all this out and see what happens. So let's build again. And my bet is the build is going to be good because we are really not using any coroutine feature in our C++ program here. So the coroutine infrastructure is not going to be needed, and these methods here are not going to be needed. But the moment we try to use this coroutine type, for example, by setting up an actual coroutine function called doWork, which is going to return this coroutine, you see that we have a squiggly line. And you see that we have no member called initial suspend, which is needed for this to work. So now if we try to compile, we will get our compiler error because we don't have the methods that are required for our coroutine to be recognized as a coroutine type here. Let's bring these guys in because I want you to see these things. We're going to take out all the others that we have commented out. And if we build with GCC, we're going to still get a bunch of compiler errors because we don't have methods that are required. You see, final suspend is required, get return object is required, and we don't have those in here. Let's bring those in, get return object, and we're going to put in final suspend and see what we get. We're going to pass this through our compiler. Again, we are going to get a bunch of compiler errors because we don't have initial suspend in. If we put it in, our absolute minimum is going to be satisfied and our code is going to compile now. Let's pass this through the compiler and show you that. And the build is good and our coroutine function we have here can actually work. So we are going to try and use these things in steps. What we are going to do is set up an auto variable. We're going to say task here. And we are going to call our doWork function. And we are going to see what happens here. Now, this looks like we are calling this function, but if we try to run this code, we should at least see this message here printed out, and then we're going to hit this point and pause our coroutine. This is what most people are going to think, but let's try and compile this program and see what happens. We're going to run the task and we're going to build with GCC. The build is going to be good, so we can bring a terminal window. Let's bring a terminal window. This is what we want. So we're going to clear. And if we run Rooster, we're going to see that our handle is destroyed when we hit the end of our program because this coroutine type object is going to be destroyed and its destructor is going to be called and destroy our coroutine frame information that we have on the heap. That's why we see this message here, but we don't see this message here. Now, why is that? Well, the problem is we are specifying that we want our coroutine to be suspended the moment you call it the first time in our initial suspend method here. And we are specifying that by using our suspend always awaitable here. If you want this to not pause the moment you call this the first time, you can return suspend never and tell the compiler that you don't want your coroutine to pause the moment you call it for the first time. And this is really the use of the initial suspend method here. You can control whether your coroutine is going to pause for the first time when you call it, or you can let it run until it sees the first suspension point, and you can decide to do that by returning suspend never here. So let's do this and see the behavior. And let's pass this through our compiler. The build is going to be good, so we can clear and run Rooster. And now you will see that we will run our very first point because our coroutine is not going to pause the moment we call it for the first time. And we get this behavior by returning suspend never in our initial suspend method. Now, most people are going to want the coroutine to pause the moment you call them for the first time because you want to get behaviors or things happening when you resume the coroutine. So I am going to take this back to suspend always because this is really the state you're going to find your coroutine types in most cases. So this is a good default. We are going to suspend always here. And we will see that now our coroutine is going to pause and we need a way to resume it by using our coroutine handle. Let's pass this through the compiler again and make sure we are pausing on first call here. And the build is good as you see here, so we can clear and run rooster. You see our handle is going to be destroyed when we hit the end of our program. And I also think it's a good idea to put in an end message that says done to know that our program has run to completion. Let's do this. And we will pass this through the compiler again to make sure this is working. The build is good, so let's clear and run rooster. We have done, and we are going to destroy our handle. This is a good thing. Now that our coroutine has paused here, we want a way to resume it. Okay, we want to resume our coroutine. The way to resume our coroutine, we go through our coroutine handle. This is going to be our handle to the computation. And notice that we have a coroutine type object here. So we can go through this object and get access to our coroutine handle object we have here. And we can use it to resume our computation. There are different ways we can resume from our coroutine handle. The first way is to use our coroutine handle as a function call. And we are able to do this because a coroutine handle is a callable object by default. So when you call a coroutine handle, it is going to resume the computation. This is the basic behavior that is wired into this object here. So let's try and use this way to do things. We're going to say task. And we're going to get our handle and we're going to call it like we call a function. Now, the moment we do this, our coroutine is going to resume from the first suspension point, which is really the start of the function. Then we are going to see that we are going to print this message here and hit this suspension point, and our coroutine is going to suspend. So we are going to see this message here as a result of our coroutine handle call here. Now, another thing we can ask our coroutine handle is to tell us if it has actually finished doing whatever it needs to do within the coroutine. If we haven't hit the end of the coroutine, this method is going to return false, saying that we aren't done yet. And if we have hit the end, this is going to return true, that we are done. So we are going to try and run the code and see that the code here is actually resuming our coroutine. Let's pass this through the compiler. We're going to use GCC to do this. So the build is going to be good. We can clear and run rooster. And we're going to see that we're going to do the first thing because our coroutine is going to be resumed, and we're going to resume from the suspension point, which is really living at the start of our function here. So we're going to resume from this point, and our code is going to run until we hit the first suspension point, which is the location where we are co-awaiting here on line 31. So we are going to see the first message here. This is what we see. And if we ask the coroutine if it is done, it is going to tell us false. I am not done yet. I still have things to do in this coroutine here, as you see in the body of our coroutine function. And one thing I don't think I have made super clear is that what makes this guy here a coroutine is that we are using a coroutine operator. We have co-await and co-wait here. So this is going to make this function here a coroutine. And the compiler is going to know that this function has the ability to pause and resume. Another thing that is going to tell you the behavior of this coroutine is the return type we have in here. So this is going to tell us the basic coroutine features we have built into this coroutine function here. You should really know this. Now we have hit our very first pause point here. And the moment we hit this point, a few things are going to happen. One such thing is that we are going to look at the await ready method of this object. And if it returns false, we will know that we want to suspend, and we will call our await suspend method. If we go back to our awaitable types in the slides, we're going to see that they have a bunch of methods. So if we use, for example, our suspend always awaitable here, we're going to see that if we co-await, the compiler is going to look at the await ready method and see if it returns false. If it returns false, we are going to know that we want to suspend, and the compiler is going to call await suspend here, and it is going to pass the coroutine handle that the coroutine is actually using. And if we want, we can grab this coroutine handle in objects of our awaitable and do things with it if we happen to need that in our C++ program. Just note the behavior and things that happen if you co-await like we are doing right here in our coroutine. So we have hit this suspension point. Our coroutine has paused, and you can see that right here, and we can resume it again and see our second message here. So we're going to do that. But now I am going to show you that we have another syntax we can use to resume our coroutine, and that is calling the resume method on our coroutine handle. So we're going to resume for the second time, and we do that by using our coroutine handle. So we're going to say task m handle, and we're going to call the resume method. This is another way you have to resume your coroutines. You can either use your coroutine handle as a function call as we are doing here on line 42, or you can explicitly call the resume method, and this is going to resume your coroutine. We can ask it if it is done, and we're going to see this information here. Let's do this. And if we resume from this second suspension point, we will see this message. And after we see this message, we will hit our second co-await point. So we are going to pause again, and our coroutine information is going to be stored on the heap. For example, we will store any parameter this coroutine function has. So we're going to store them. We will store our local variables if we happen to have them. And we will store the return point when we resume this coroutine here. So we will store this information. For example, line 34, this is where we are going to resume from if we resume from this suspension point. And we will know that the moment we resume this coroutine again, we will run this line here. This is what we mean. So we are going to resume, and we will see the second line here printed out. Let's do this and see if this is actually the case. The build is going to be good, so we can clear and run Rooster, and we will see doing the second thing. We are going to ask our coroutine if it is done, and it is going to say, I am not done yet. It is going to return false, so this is a good thing. We can resume again, and if we resume from this point, we will see the second message here, and our coroutine is going to run to completion. And if we ask the coroutine if it is done, it should tell us that it is done. Let's resume again. So I am going to copy the code here, and we are going to go down and run it. We're going to say for a third time, and we are going to resume and ask the coroutine if it is done. Let's pass the code through the compiler. The build is good, so let's clear and run Rooster. You see that we are going to say that we have our third thing done here. The message is here. And now the coroutine is going to resume from the point here. It is going to print this message, and the coroutine is going to run to completion. And if we ask our coroutine if it is done, it is going to tell us true, I am done. The coroutine has run to completion. Now, the coroutine has run to completion, and if you try to resume again, that's going to be a recipe for disaster. Let's show you what might happen. Let's try and resume it again a couple of times. So this is a really bad idea. I am just showing you that this is bad. Don't do this. We're going to try and resume it again, and we're going to see what happens. Let's put a simple separator here to see it before we do something really bad. And we can pass this through the compiler. The compiler is going to take it because the compiler thinks we know what we are doing. The build is good, so we're going to clear and run Rooster, and you're going to see that after we print this separator here, our program is going to try to run. It is going to try to resume the coroutine, but it is going to fail. And you see that we don't see the done message here because our function, our main function, I should say, hasn't even run to completion because we are trying to do something really bad. We are trying to resume a coroutine that has already run to completion. So you shouldn't really do this. If you try to do this, you will be setting yourself up for a disaster. I want you to be aware of this. Let's take this out because I don't want to leave you with bad code like this. We're going to try and build again. We're going to pass this through our GCC compiler. The build is going to be good. We can clear and run rooster, and our program is going to run to completion. And when our task object goes out of scope, we will call our destructor, and the destructor here is going to be called, it is going to call destroy on our coroutine handle, and this is going to destroy whatever coroutine information we had stored on the heap, because we don't need that. And that's because the task that actually needs this coroutine handle is going to be destroyed. So everything that is beneath this object here is going to be destroyed. That's why we see the message here that our handle is going to be destroyed. Okay, so this is really all I had to share in this lecture, showing you how we can use our coroutine type. If you have a coroutine type ready, the way to say that your function is a coroutine, you have to return some kind of coroutine type. And inside the function, you have to use coroutine operators, for example, co-await, co-yield, or co-return. In this example, we wanted to focus on the co-await operator and show you what happens if you try to pose your function or coroutine using this operator here. Again, these methods here are required for your coroutine type to be recognized as an actual coroutine type. We have run this example here using GCC mostly, but we can also pass this through the compiler from Microsoft to make sure that this is actually working. You see the world is good, so we can clear and run rooster, and our program is going to work as it is supposed to. We are going to stop here in this lecture. If you have any problem, please do remember to ask. We are going to head over to the next lecture and play with the co-yield operator. Go ahead and finish up here and meet me there.